So we're continuing to talk about conditional probability, and let's take a look at example 6. So it says, suppose you pick 3 cards from a deck. What is the probability that they are all kings if the cards are not replaced after they are picked? So this one is still conditional probability, but it is different than the last couple of ones we've done. The last couple of ones, right, says we started with, pick a card, choose one card. What's the probability of this given this, right? The example 5 and 4 you're choosing 2 cards, but we're focusing on the probability of just the second card. Now with example 6, we're now choosing 3 cards, but we want to know the probability of all 3 cards together. So we're going to have 3 probabilities for this one. So we want to know the probability, right, of all 3 kings. And so the way that this works is it's going to be, right, the probability of the first being a king times the probability the second is a king, right, given the first was a king. And then the last probability is what's the probability of the third being a king? I'm going to shorthand here because I'm running out of room. Given the first and the second were kings, right? So we have 3 separate probabilities. Let's go slowly and take a look at how we would look at this. So, and it says they're not replaced, right? So without replacement. So the probability that the first is a king, right? Well, I have 4 kings in my deck, right, out of 52. So it says they're not being replaced. So we take that first king we're given and we put it aside. So this affects my probability of my second, right? So the second probability, I'd start with 51. But now I also have 1 less king to choose from. I have only now 3 in my deck. So I've already chosen the first king. I set it aside. Now the idea in theory is, okay, the probability of choosing the second king is 3 out of 51. So I choose it, I set it aside. And so my third probability now is only going to have 50 cards to choose from. And since I've already chosen 2 kings, I only have 2 kings to choose from. So we can go through and we'll just want to find this as a decimal. So 4 divided by 52 times 3 divided by 51 times 2 divided by 50. So you'll notice, right, this is actually a really small number. The e to the negative 4 is saying it's in scientific notation, right? So if I write this just 1.80995, right, times 10 to the negative 4th, what it's saying is you need to move over your decimal 4 spaces to the left. It's a really, really small number. So if I do this, I end up with 000, roughly 181, right? A very, very small probability. And if you think, right, the probability of choosing 3 kings from a deck should be fairly low. And this is even without replacement. So I gave a very similar example with example 7. The only difference it says is they are replaced. So I'm going to start sort of the setup exactly the same. All 3 kings, right? The probability of the first king times the probability of the second king, right? Given the first king, times the probability of the third king, given the first and second were kings. Okay, so the probability of choosing a king for the very first card, right, should be the same, 4 out of 52. So the idea with this one, since it's being replaced, is we choose the king, like look at the card, and then we put it back in the deck. So when I'm about to choose the second card, I still have 52 cards to choose from, and I actually still have 4 kings in my deck. Because I just looked at it, I didn't actually take it out of my deck. And so when I'm about to choose the third card, the same thing. I still have all my 52 cards, and I still have all my 4 kings in there. So you can do 5 divided by 52, right? times 4 divided by 52. You can do this 3 times. You could also raise it to the third power. That would work. 2, 4 divided by 52. So again, still a small decimal, a little bit bigger than the last one, right? So 4.552, right, times 10 to the negative fourth. So we move over the decimal 4 spaces. So 0.000455 would be my probability. So it is higher, right, slightly higher. But just sort of notate that difference between they want a probability of all of the cards that we choose and then the difference between with and without replacement. So if I go back and talk about independent and dependent events, example 6 would be an example of dependent events, right? Because we're doing without replacement. As with example 7, since whatever we pick, we're replacing it, this would be independent events. And you could actually, independent events, you could have actually just written, let me go ahead, and instead of writing it in conditional probability, you could have actually just written the probability of the first being a king times the probability of the second being a king times the probability of the third being a king, because they were all independent events. So there's really no conditional probability with example 6 since the events are independent.